That 200 volt battery and 100 volt battery are connected to three resistors 20 and 132 and 60 ohms as shown. Find the current through each resistor. And that is a question, and the potential drop across the 132 ohm resistor or whatever, so that can be asked. So here we have not been given any direction of current or anything, just they have given. So how to use Kirchoff's law to solve this circuit? First, name the junctions A, B, C, D, E, F. So my idea is not to solve that immediately, but I'm going to tell you how many ways we can apply. So that's what. So here the first thing is there are three loops: A, B, C, F, A, one loop; F, C, D, E, F, another loop; A, B, C, D, E, F, A, another loop. So anything you can do. And junctions, here is one junction, here is one junction. And know that if current comes through this, the same current has to come out. Suppose assuming that this current in this is I1, so I1 comes here, I1, and you can choose anything. So the current comes here, it divides into two. Let us name that this is I2 and this is I3. If I3 comes here, I3, I2 goes through 60 ohm and then the battery and then comes here, this is I2. Okay, if through this current is I1, then the current here also I1. Now two junctions are there, junction C and junction F. So here the possible junctions are like C and F, two junctions. The loops, the possible loops are A, B, C, F, A, and then F, C, D. See, it's not necessarily F, C, D, E, F. It can also be C, D, E, F, C. So F, C, D, E, F, or the whole loop. When you consider the whole loop, you don't have to consider the in-between thing. So A, B, C, D, E, F, A. So three loops. Okay. Let's first apply Kirchoff's current law at junction C. So I1 is the current toward the junction, I2 and I3 are away. So I1 minus I2 minus I3 equal to 0, or you can write I1 is equal to I2 plus I3. This is one. Then the next thing, look at first loop, A, B, C, E, F, A, B, C, F, A. So Kirchoff's voltage law at for A, B, C, F, A. So Kirchoff's voltage law we know. On the left hand side you have to write summation of IR, on the right hand side you are supposed to write the summation of the battery voltages or EMFs. IR, U and current are in the same direction positive, U and current are in the opposite direction negative, negative to positive of the battery plus, and positive to negative of the battery it is minus. Okay, so first look at A, B, C, F, A. A to B, if you go, the current I1 through 20. So U and current is also from A to B, you are also from A to B. So it is 20 times I1. B to C, no resistor. C to F, when you come, I3 and current is also from C to F, you are also going from C to F. C to F. So it is plus 132 I3. And there are no other resistors here. So only two resistors in this loop, then there will be two components on this side, equal to, when you go from A to B, you are going from negative to positive. So it is negative of the battery to positive. So you move from A to B and negative to positive we are supposed to move. So it is plus 200. Then this can be our equation. Let's call this equation 1. Let's call this equation 2. Then the next loop is F, C, D, E, F. So apply Kirchoff's voltage law for F, C, D, E, F. Then when you move from F to C, u and current are in the opposite. U move from F to C, current is from C to F, so it is minus I3 into 132, that is minus 132 I3. And then C to D, no resistor. D to F, if the current goes this way, it has to come this way, so 60 through this, current I2 through 60. You are also going from D to E, current is also from D to E, so it is plus 60 I2 equal to, there are no other resistors in this loop. Then when you move this way, when you go from D to E, F to C, C to D, D to E, when you go from D to E, you are going from negative to positive of the battery, so it is plus 100, so it is plus 100. Now these two equations are sufficient to solve. We can replace from this relation, you can substitute I1 is equal to I2 plus I3. There is already I2, I3, and you can substitute it here and solve. Or you can also do the other thing. What is that? You can write one more loop, A, B, C, D, E, F, A. So for apply Kirchoff's voltage law for A, B, C, D, E, F, A. When you go from A to B, you are moving from A to B, current is in the same direction, so it is 20 I1, so it is 20 I1. And B to C, C to D, there are no currents and there are no resistor. D to E, when you move 60, you also move from D to E, current is also from D to E, so 60 I2, so plus 60 I2, 60 I2, and there are no other resistor, E to F, F to A. So A, B, C, D, E, F, A, only two resistors. Okay, then on the right hand side we are supposed to write the battery potential. When you go from A to B, battery negative to positive, so plus 200. No other battery here. D to E, again negative to positive, so it is plus 100, so plus 200 plus 100, so 200 plus 100, that is our fourth equation. Or this can be written as 20 I1 plus 60 I2 equal to 300. So you can cut 1 0 here, and then you can also divide by 2. So divide by 20, if you do this, actually I1 plus 3 I2 equal to kind of 15. This is our fifth equation. We have fifth equation, and you can also use any one of this equation to solve. So when you divide this by, let us say, here I1 and I2 are there, I2, I3 is there, I1, I3 is there. So from this relation, if you want to write anything, so I3 can be written as I1 minus I2 from equation 1. So substitute it here. What you can do, 20 I1, so it is 20 I1 plus 132 into I3 is equal to I1 minus I2. So I1 minus I2 equal to 200. Sixth equation. So instead of naming it as sixth, we can go for one more thing. So it is 20 I1, so I can, so 20 I1, 132 I1, so 152 I1, 152 I1 minus 132 I2 equal to 200. So, and here if you want, you can just multiply with 152, or when you do that, it is 152 I1 plus 152 into 3, so it can be like 152 into 3 is 456 I2 equal to, it is 15 into 152. So that is one way of doing it. Or you can also solve this. So you can also use this instead of this equation. You can actually reduce this equation. That's up to you. You don't have to worry about it. Whatever is the case, then the answer will come. That's what. So 15 into 152 equal to 2280. 2280. When you solve this, you will get I2. So it is subtract. So when you subtract this, these two will be cancelled. So 456, 8, and then 8, and then 588 minus 588 I2 equal to, again, 2480 2080 minus 2080, then I2 equal to 2080 divided by 588 will give you 3.53 ampere. So we have found I2 as 3.53 ampere approximately. 3.537 will come. You can approximate it as 3.54 ampere. I2 is found. If you substitute it back I2 here in this first equation, so I1 plus, so this I into fifth equation, I1 plus 3 times 3.54 equal to 15. So 3 times 3.54, let me 3.54 into 0.54 into 3, 10.62. so I1 equal to 15 minus 10.62. you will be getting 4.38 approximately. So I1 and I2 are found out. So we know that I1, this current is 3 point, this is I1 is actually 4.38, so this is 4.38, and I2 is actually, we have found out 3.54. you know I3, so I3 is equal to I1 minus I2. 4.38 minus 3.54, if you subtract it, 8 minus 4, 13 minus 13 minus 5, 13 minus 5 is 8, so 0.84. like that you can calculate the current. Then what is the potential drop across 132 ohm? The current through 132 ohm is 0.84. potential drop across 132 is current into resistance, that is 0.84 into 132. So if you calculate 0.84 into 132, that will be roughly about, that is about V132 equal to 110.9 volt. So like that we can use this Kirchoff's law to solve complicated circuits.